Okay. Hello again, everyone. Welcome to the third and final day of this 3-day webinar on algorithms in everyday life. For those of you who are joining us for the first time, my name is Dr. John Lowen, and I'm a faculty member here at the School of Integrated Innovation at Chulalongkorn University in Bangkok, Thailand. Weather today, 32 degrees Celsius out there, under a slight haze of humidity. 60% chance of thunderstorms this afternoon, so it's only going to get more humid. So with that very important information out of the way, let's get started. So this is day 3, as I mentioned. Just to summarize what we've talked about so far, for those of you who may be joining the first time. Day 1, we started with an introduction to algorithms, including a definition, some of the broad issues, and then we looked at some examples of algorithms around us and how they affect us in our everyday lives. For day 2, we got a little bit more technical, and we looked at how to measure the efficiency of algorithms using big O notation. And then we looked at divide and conquer as an efficient way to search and sort data. We then equipped ourselves with a simple toolbox specific for designing algorithms, specifically how to write pseudocode and how to do flow charting. And lastly, we used these 2 different methods to design a simple algorithm which we called the WOO algorithm, to increase our chances for a yes when we ask our crush out on a date. Now, I'm already receiving pushback on my version of the algorithm. Part of the algorithm was meeting the parents, and I think the general consensus on this was that that was way too early to be meeting the parents. So I should probably do a second iteration, go back and redesign my algorithm, and refine my algorithm to make it more robust. Today, we're going to get a little philosophical. We are going to look at qualitative information and how we try to make sense of this information in the context of algorithms. Qualitative information can complicate things a little bit. I will provide you with some interesting examples of how qualitative data may be different and how the human mind can process this information in an algorithmic way. Now, this is a generalist discussion. But as you will see from the examples, there are many useful applications with qualitative information when you think about processing that information algorithmically. Lastly, we'll look at examples of where algorithms may be useful in this new landscape of COVID-19. So the structure for today, same as the previous 2 days. So I'm going to talk for about 40 to 45 minutes. I'm only asking one poll question. You're encouraged to post your responses to the chat window as in the previous 2 days. And again, I have the lovely and talented Dr. O beside me compiling your responses and your questions, and she will provide that to me when we get to the second part of the webinar, which will be about 15 minutes today, where I'll provide a summary on your responses from Dr. O, and I'll endeavor to answer any questions that you have as best I can. So let's get started. All right. First thing I want to talk about today is the idea of thinking about algorithms. So on day one, we took a look at how algorithms can cause disruption, but we didn't go into too much depth. If we think a little bit critically about algorithms, what are some of the things that we should be focusing on? Now, there's a great article out there by a fellow named Kitchen, and he states that algorithms are created for purposes that are often far from neutral. So the person or the people or the organization that designed the algorithm, they may be designing the algorithm to create value and capital. So of course they want to make money off of this. They may also be trying to nudge behavior. So they may have a reason for outputting the information that they do, and it's to get you to perhaps the consumer to move in a particular direction. The third item on there is to structure preferences in a certain way, and then again, to best perhaps get you to subscribe or to purchase or to become part of what it is that is on that particular site or that application. And then also to identify and to sort and to classify people. In other words, someone had a reason to create that algorithm, and the result of their creation may be also a reflection of their bias. For example, age bias, cultural bias, race bias, political bias, etc. So if we're thinking critically about an algorithm, we might be thinking about how that algorithm was designed and why it was designed in that particular way. So in a sense then, algorithms are not just what programmers create or the effects they create on certain input. So users make more and more decisions based on the results of algorithms. So algorithms plan their diet for breakfast, plan their route to work, rank their news feeds on social media, provide product placement in advertising space, provide potential dates on Tinder. So how good are these algorithms? Are there built-in biases? How consistent are they? In some cases, perhaps not very much. So with these algorithms, they are what users make of them on a daily basis. So users are using these algorithms, and as we move forward in time, of course, algorithms are becoming more and more a part of our everyday landscape. So what are some examples of algorithms that we see and that we use quite commonly that we may not know much about? The first one here is I've got here is Facebook. So when you, and that may be aging myself a little bit here, I don't know how many of the younger generation use Facebook, but what you see in your feed and the order in which you see it depends on how you interact, for example, with your friends. And also from the scraping of your information by Facebook as to what you are or may not be interested in. So the sorting algorithm for Facebook does not work in a static, fixed manner, but it works based on the preferences for each individual user. So its parameters then are contextually weighted, and they're also fluid. They're changing. To us, though, Facebook is a black box algorithm. We don't know exactly the details of how it works. So we don't know how the relevant to you listing is prioritized or how it's even set. But we do know that it takes into account, so from the research I did on this topic, there's approximately, people say, 100,000 factors in generating your news feed, so the news for you. And this is the default setting in Facebook. You can change it, but when you first go into Facebook, log in and access it, that's the feed that you see. The next is Kayak, so booking an airline ticket. So the options, prices, and results may vary depending on who you are identified as and where you are accessing from. And again, this is a black box algorithm. But empirically, I have seen between my wife and I, when we're in different locations, different prices and different options available based on the algorithm that they are using. So how exactly does the algorithm work? Well, I don't really know, as it is black box. But there are differences depending on who you are and where you are. The third example here that I have is Google and the autocomplete tool that you see in Google. So it gives different results from different locations. So it leads people in different directions. So depending on where you are, what it is that you ultimately end up searching and how you search for it may vary. So how good was the direction that you were sent in? That's a question that you may consider. So next let's take a look at the idea of qualitative data versus quantitative data, because we're heading more in a qualitative direction. So to gain a complete understanding of algorithms and the work they do in our world, these particular people, Barakis, Hood, and Zeiwitz, I don't know if I got that name right, they suggested what's called a well-rounded approach. So not just the classical computer science approach, which you see in many textbooks, right? Textbooks called data structures and algorithms in Java, data structures and algorithms in Python. Those are conventional computer science tests where you hammer out an algorithm based on the best efficiency, which is what we kind of saw yesterday, right? But these authors, Barakis et al., say take a careful, thoughtful, and researched approach to developing an algorithm. And what should that include? Well, of course, it should include the technical side of it, which is the approach that studies algorithms as computer science. But also, you should take into account the sociological side, or sociological approach, that studies the algorithms as the product of interactions among programmers and designers. So what I just mentioned a slide ago about perhaps having built-in biases, depending on who is responsible for designing the algorithm and how they go about that designing process. The third approach is the legal approach, and that studies algorithms in the context of legal concerns. So anytime you're in the development of an algorithm that may be dealing with sensitive data, such as personal information, banking information, medical information, it's really important to understand the legal ramifications of the information that you're using within that algorithm. And the fourth is the philosophical approach that studies the ethics of algorithms. Okay, so when you're thinking about algorithms, a well-rounded approach is something that you should seriously consider. More on qualitative versus quantitative. So quantitative data, which is what we've been working with and talking about predominantly so far, is basically hard numbers, right? So they come in the form of lists, they come in the form of arrays, spreadsheets, just a bunch of numerical data. And most algorithms are written in many cases very well to sift through this numerical data. So they do searching, they do sorting, they create lists, they categorize. That's what they do, and they do it very well. Qualitative data, on the other hand, is much more subjective. So qualitative data may include information or data about how a person feels, about something, their opinion on a topic, or how they go through a process step by step. And often this data is approximate, using values such as few, not that much, more than usual, and quite a lot. And there's a lot of subtleties built into human language and human dialogue that are much more difficult for a computer to be able to interpret and to perhaps quantify. So some argue that algorithms are purely a mathematics endeavor. So, for example, focusing solely on efficiency and providing optimality from a purely technical perspective. So how fast do they run and how quickly do they produce accurate output? So efficiency and robustness, and that's it. And this is the approach in many computer science texts. So if you are taking a course in computer programming around data structures and algorithms, you'll notice that there's not a lot of discussion in that textbook about how you feel about algorithms. It's mostly just about searches and sorts and bubble sorts and merge sorts and all the other sorts that are either efficient or non-efficient uses depending on what it is that your algorithm is trying to accomplish. So that's the one approach. The other, some posit that coding an algorithm has a subjective component, what we've mentioned already, right? Shaped by ideology, shaped by politics, shaped by local customs, local culture, and many other different items. So an algorithm is inherently driven by mathematical objectivity, right? Numbers are numbers, you crunch the numbers, but the logic created to drive that algorithm may be shaped subjectively, okay? So human beings are human. They have opinions, they have ideas. So when they design algorithms, especially complex algorithms, some of that opinion and some of that subjectivity may actually implement or manifest itself in that design. So that's something to think about from more of a philosophical perspective. All right, so let's do a shift then, a slight philosophical shift towards this idea of qualitative thinking. And it's the domain of like machine learning and natural language processing, and also expert systems, which I'm going to talk a little bit about today. So designing an algorithm involves the process of trial and error, collaboration, and negotiation. Remember earlier on in this series we talked about how certain algorithms may be mature. They've gone through many development steps. They've gone through many iterations. And some algorithms may be raw. It's their first iteration. A lot of the bugs might not have been worked out yet. So algorithms are edited, revised, deleted, restarted, shared, iterated, which is, again, the process of going through the development again and again. And they're also stretched out over time. So they may be early on in their development cycle, or they might be later on in their development cycle. So how does qualitative thinking fit into all of this? Well, suppose you're traveling in rural Canada and Google Maps is not working. So believe it or not, there are actually places, for example, where I grew up, where cell phone coverage doesn't exist. So your Google Maps stops working, which is your quantitative methodology of finding your way from A to B. I have to say, in Bangkok, if my Google Maps is not working, I would probably never find my way out. You come across a local. So you walk up, so they're in their yard. You walk up or you drive up and you ask them for directions. So you're lost and you want to find access to the main ferry terminal because you've had enough of this remote place and you want to get back to civilization. Now, if this person were a mathematical algorithm, he or she would act something like Google Earth, right? Go 320 meters in that direction, take a right, set your course to 355 degrees, go 1.34 kilometers, set course to bearing of 48 degrees for 846 meters, go up to a bearing of 98, drive 634 meters, and you will reach your destination. But is that how the conversation with this local really goes? No, it'll be actually quite a bit different. So they would say something like, oops, sorry, wrong way. They would say something like, well, you know, drive north for about 5 minutes, give or take. When you pass the yellow house on your left, turn right. Well, you're going to have to go for a few more minutes, past the Esso gas station, until you see the church on your right. Now, make sure you go past the church and then make the first right turn after the church. Go another minute or two, and you'll be at the ferry. Okay, so that's the way that a human being would actually algorithmically process the process of getting from point A to point B. And as you can probably see, there's quite a bit of difference between mathematically how that would be calculated and then qualitatively how a human being would present that information. Now, this is quite a simple example. But for me, where it gets more complicated, well, where for everyone it gets more complicated, and for me much more interesting, is when the human mind can make some amazing decisions based on many sources of inputs that are variable at best. And some of these sources of inputs to the untrained mind may actually be chaotic, which means an untrained mind cannot make any sense of that data whatsoever. So can an algorithm be in your head is the next question. So again, we're going philosophical today. Well, human beings compute all the time, so I would posit that the answer would be yes. So they take in many different sources of information, and they make decisions based on those sources. Should I stay? Should I go? Should I buy? Should I sell? Should I go this way? Should I go that way? Is today the right day to do this? Is it the right day to do that? Often the only data they have is qualitative and or is subjective, so it's information that they have in their mind. Now, mathematicians may argue that this information doesn't count. But there's so much of this data around us. And if you're like me, you don't have a spreadsheet in your head. Most human beings don't, I believe. At least I know I don't. So what's the difference between data and information? Because I'm talking about data and information here. Well, the true definition of data then is raw, unorganized facts that need to be processed. Data can be something simple and seemingly random unless it is organized. So when data is processed, when it's organized, structured, or presented in a given context so as to make it useful, then it becomes information. Okay, so data is raw, information is our interpretation or perhaps an algorithm's interpretation of that data. So often a subjective view on data is someone's interpretation of what that data means. And sometimes individual A can make much more sense of the data in their immediate proximity than person B. Okay? So data isn't just data. Data can also be used to make sense out of what's happening around us. So poll question 1, I just have one poll question today. What are some sources of qualitative data around you that you think might be useful or that you're aware of? So think about that as we go forward here. And just post your response, if you have one, to the chat section. So qualitative thinking and algorithms. So how can we make sense of all of this then? And again, this is a level of abstraction higher than yesterday. This is most certainly a transdisciplinary area. And it's an area where I've spent a lot of time and research, particularly when I was writing my thesis for my PhD. And what I find interesting is the idea of being able to bridge knowledge systems. So being able to bridge qualitative data and marry it with quantitative data. And you can do that to some success using algorithms. So for example, ways in which to quantify qualitative thinking. First off though, how does qualitative thinking fit into algorithms? So can you think of some examples where human beings use qualitative thinking algorithmically to their advantage? And so I have a couple of interesting examples here that I'd like to share with you today. And it's a bit of a storytelling venture, but I find these examples quite fascinating, and they were part of my research journey, so I thought I'd share them with you today. The first of these is the idea of algorithms of navigation. So getting from point A to point B. And like I mentioned, these days, this art and science of navigation has been lost somewhat because algorithms and GPS location devices take some of the mystery of this away. But this wasn't always the case. So a classic mystery, if we go back in time, of modern times being like, say, the last 500 years, is the human inhabitation of incredibly remote Pacific islands. So how did these people get there? And how did they get around? Because they didn't just stay on one island. They actually moved around quite a bit for reasons of food gathering and distribution of populations and such. And some of the stretches between these islands were hundreds of kilometers in distance. I think one of the longest stretches is like 600 to 700 kilometers, so a long ways. Early Western, for example, European explorers thought that this happened purely by chance. So when they came upon these peoples in these remote islands, they had nothing written down. They had no form of documentation. They were oral cultures, and all of their information was passed by word of mouth. So all of their information was in their heads, essentially. The peoples of these islands, they had no tools, they had no formulas, they had no algorithms, visual algorithms, for navigating these vast distances. So plainly, the finding of new islands in the beginning must have been, like all discovery, for example, the Europeans were doing it in the 17th and 18th centuries, as an example. It was fortuitous. So coming across an island would have been fortuitous. You've never been there before, there it is. But subsequent navigation would be both by deliberate voyages, so you go back there again, because you like what you saw, and also involuntary. Perhaps you got blown off course by a storm and you came upon another island. But how do you then get back home? And how are you able to return again and again unfailingly? So the early position on this was that these people purely found themselves there by luck. But what the European explorers didn't take into consideration was the right questions to uncover the details of the techniques of navigation were generally not asked at all. The very idea that people without instruments or writing could have developed an elaborate and effective method, basically a very complex algorithm of navigation, it was so utterly foreign as to not even enter the minds of most Europeans. And now, even if they had asked the right questions back then, they might not have got the right answers that would have convinced them, because this knowledge back then was also very carefully guarded. So it's worth re-mentioning here quickly that an algorithm may be used as a method of providing inputs, followed by efficiently sorting through data, so doing a process, right, to provide relevant outputs. So with everything around them as inputs, how do you produce the right output? So the right direction and distance of travel. Well, that's easy these days. You plug your destination into your phone, you hit directions, and presto, you have a route. But back in 1972, a fellow named David Lewis, who was a sailor and an explorer, he was asking these same questions. And he wrote a book called We the Navigators. And in that book, he documents how he set out to rediscover some of these techniques of navigation. So he sailed the most remote routes with the few remaining knowledge holders, so the few remaining people who had these algorithms in their head, where they used ancient techniques devoid of any sort of modern navigation. They didn't even have paper and pen, so nothing was even written down. So it turns out that the minds of these few navigators that he had the pleasure and the luck to be able to discuss and to ask questions to, they were incredibly adept at taking inputs from multiple sources and processing them and producing accurate outputs through the algorithmic process in the brain. And this could not be accredited solely to celestial navigation, so navigating by the stars, which is what many European explorers had said was what was making these journeys successful. Turns out, through Lewis's investigation and his questions, that there were many sources of data that were not even considered by European navigators. So where European navigators saw chaos, these local expert navigators took that chaos, interpreted it as data, and then made information out of that data. So they were amazing at converting this data around them, which looked chaotic to many, into information. And so there were a whole bunch of pieces of information or data that they used as information. So what are some of the things you can think about that they might have used? Well, it turns out there was a whole bunch, like I say. So what were some of those data sources? Well, they took into account wind direction, which European navigators also did somewhat, trade winds. But the local expert navigators were much more detailed about wind direction. In fact, they had many of these cultures what was called a wind compass. And that wind compass had all of the different directions of the wind, and they knew by how that wind felt as to which direction it was blowing from. So they could approximate and find their direction based on wind. Also, wave swell patterns. So as waves reach islands and past islands, they're refracted, as that diagram on the top right shows you there. And by the refraction of this pattern and how it interacted with other swell, they could approximate their distance between two islands, as an example, using swell patterns. Also, phosphorescence. Phosphorescence is glowing underwater plankton. And with many islands in a particular region, for example, they would know if they found phosphorescence at nighttime, that if they were sailing through it, that they were maybe about 8 or 10 kilometers from the land that they were trying to navigate to. Also, watercolor. So effects from land, perhaps river outflow, and then also the water depth. So as water depth decreases, the color of the water changes. So they could use that to indicate how close or how distant they might be from an island. Also cloud types, so effects from land, direction of movement, and then also animal presence. So different islands had different populations of birds, and when and which direction you see those birds traveling might indicate where they're coming from in regards to an island or where they're going to. So there's all of these things that are happening around them that Europeans interpreted as chaos was actually very organized and structured, and they could use this information to calculate where they were and how far they had to go. So, I mean, that example may be dated today with GPS, but it's really interesting in that the amount of information that these expert navigators processed completely within their own minds was quite impressive. A second example that's a little bit closer to the research that I did, so I actually used this particular paper as part of my own research as a reference. Fisher knowledge as an expert system. So the first example was basically just talking about humans being able to interpret and process information qualitatively. But if you have this qualitative information, how and in what way can you take this qualitative information and interpret it quantitatively? So this example here was with fisher people in a small island nation in the Caribbean called Grenada. Grenadian fishers are adaptive experts because they have the ability to learn from and deal with new situations. So this is like many fisher people worldwide. They generally have to deal with many different inputs of information: weather, wind, not much different than the navigators, weather, wind, temperature, season, as to where the fish are and how they might catch them. So the researchers in this example, they created an expert system from the knowledge obtained from the fishing experts. So they actually created algorithms that quantified this qualitative information that the fisher people were providing. So the information that the fisher people relied on was observation, experimentation, experience through catching fish, evaluation, and learning to adaptively improve their understanding of the marine ecosystem around them and the resource. So that's constantly in flux and constantly in change. So up until this project was undertaken, again, all of the knowledge for how to fish in these waters was in the minds of these experts and nowhere else. It wasn't written down, wasn't documented. It was all just oral knowledge that was passed down basically from generation to generation. So what the researchers found was from this qualitative information, they identified basically 9 categories of knowledge. So the idea here is how can we classify this knowledge in a way that we can then convert it more towards quantitative information. So you can see here we have 9 categories, and I don't need to go through all the details of these. But from these categories, what you see on the right-hand side there is an example of the expert system that they created. And those of you who were with me yesterday, or with us yesterday during the webinar, will see that, boy, that looks an awful lot like pseudocode, right? So what we've done is we've gone from qualitative information and we've quantified it by creating these rule sets that can go through all of these sources of knowledge and create a system that can then simulate the process and generate outputs that can then be analyzed to their accuracy. So taking, again, qualitative knowledge and converting it into some form of quantitative knowledge that can then be analyzed. So again, this expert system algorithm ended up being conceptualized as a decision-making rule structure, which followed a very pseudocode-like structure. And an algorithm was created to understand how these human experts, so a bunch of them were providing this knowledge, how they use technological and ecological knowledge. So they created what are called heuristic rule sets, which basically, though, is simple term is just logic, based on the fisher's description of how they make decisions. Okay, so there are some distinct advantages to this kind of system, but there are also some disadvantages. So if you're thinking again from your philosophical perspective, so making well-rounded and asking well-rounded questions, the advantages are you can run millions of simulations, right? In the time it takes to do one in real life. And you also have knowledge from multiple sources. So it's not just one fisher person's knowledge. It's an amalgamation, a joining of all the fisher people's knowledge. So those are the advantages. Again, you've got an expert system. You can run simulations. And hopefully from those simulations, you learn and are able to understand what certain inputs will produce, what sort of outputs they will produce. Disadvantages to this kind of system. It's difficult to extract expertise from human experts. Many inputs mean that the solutions vary greatly. So it might be that you run many simulations and the outputs are consistently different. The other disadvantage here is that this is knowledge that is quite often very personal and very protected, because passing on this information is information that is valuable. So there is this consideration that making this information into a system and making it public might not be advantageous to the people who are using this knowledge to make their livelihood. Okay, so that's an example of an expert system. So quantifying this qualitative information, this qualitative data that's all around us. So why is this important? Well, indigenous knowledge helps greatly to meet the broader objectives of society. So for example, conserving the environment, developing sustainable agriculture and aquaculture, as an example, ensuring food security. And it gives indigenous folks who are more connected to the land generally have a deeper understanding of the connection between land and people. And they value those connections quite deeply. So the expert system consisted of a knowledge base and an inference engine using these heuristic rule sets. So the inference engine is basically the algorithm, and it's just a set, a certain sequence of if-then-else statements that help, again, to quantify the qualitative information. And also, if we look at this in a remote rural context, expert in certain fields, like these navigation experts, are quickly disappearing. And in many cultures, the expert information is oral in nature. It used to be passed down from generation to generation, but that practice isn't always the case anymore. Now, machine learning is being used more and more as a method of sifting and sorting qualitative data. So you can see here on the right-hand side, I put in a word cloud. And this is kind of the foundation or the basis of where machine learning came from. So these days, machine learning involves screening, sorting, and sensing this sort of data, for example, by using sentiment analysis. So machine learning is another way that we can use computers and algorithms to sort and make sense of qualitative data. Okay, so now let's move on to taking a look at what I have called here the socio-technical approach. So again, this is the idea of having a more well-rounded approach to designing algorithms. So asking a question such as, how do algorithms make a difference in everyday life from a social perspective, not just a profit objective or from a numerical perspective, but also from a social perspective. So when algorithms are introduced that affect social fabric, there can be pushback, right? And the way we can mitigate this, or at least have a better understanding of it, is through conducting ethnographies of how people engage with and are conditioned by an algorithm. So human-computer interaction is an area of research where we can dig into this a little bit deeper. So how do these algorithms affect people and organizations? Now, an example I put forth here is the COVID-19 tracker, and this is used in many different areas of the world now. It's sort of becoming part of the new normal. In Bangkok, there's a COVID-19 tracker that tracks current cases and also it tracks hotspots within the city, and there are definite advantages to this kind of an application that uses algorithmic software to give real-time information, so it's very quick. It gives us places to avoid. It gives us an understanding if things are getting better or worse. And all of these things are, of course, these things are what we are really concerned about when we are out and about in our daily lives. But is it all positive? What about privacy concerns, right? What if you're a business in a hotspot? How does that affect you? How does it affect what you do and what you sell? But also, what if the algorithm is not accurate? As we've seen, if you're following the news, the testing for COVID-19, all of these tests are of various varying qualities. So it may be that you're identified as being positive, but you're not. And the other side of it is that you may have been identified as being negative, and you are. So what if the data is flawed? But these type of applications may become part of the new normal just because of the prevalence of COVID-19 within our society. And so they may become more mainstream. Another example I have here that I found was in New Yorker magazine. And it was about an organization called SideHide who created an app. And it's a digital app that streamlines hotel reservations. So the idea is that you have your own personal passport that uses facial recognition and AI. So there's an algorithm that has built-in verification, and it simplifies hotel check-in. There's another company called Unfido, or Unfido. I actually don't know the actual pronunciation, but I'm going to say Unfido. And they introduced an algorithm to track COVID-19 results. So it allows users to take serology tests and upload it to a private server, and it uses facial recognition to unlock results. So essentially you end up with a form of an immunity passport. So these two companies actually created a partnership. So SideHide CEO, a fellow named Joaquin Hultin, I believe he's Swedish, saw a way in which the algorithms of both companies may be combined. So he asked Unfido to build that capacity into his app. So this immunity passport also became part of his hotel reservation application. And he's calling this an immunity passport. So this is a very recent article. So as of May 22nd this year, Hultin drummed up $100 million, according to this article, in venture capital, and he's starting pilots in Miami in hotels in June, so basically now. The idea is to let the hotel staff know which guest is safe, okay? Now, other possible use cases for his application that he's considering, or that he and Unfido are considering, are virtual voting, passport visa applications, secure ways of carrying out contact tracing, tracking the spread of the virus without compromising user privacy. So this is all great, right? Well, not so fast. There are some issues, as the author of the article, Sue Halpern, raises. She says, the deployment of immunity passports raises a number of logistical and ethical concerns. So what are some of these logistical and ethical concerns? Well, I've listed a few of them here, and this is by no means comprehensive. There may be more. But the first one I've got here is the lack of comprehensive testing, particularly in the US, right, where testing has been erratic in places. And even if that testing is there, the way that people are acting does not align with the testing that's occurring. The second issue is too many unreliable tests on the market. Again, if you've been reading the news, you've been seeing a lot of this. False positives, false negatives. So that's another issue. Also, COVID-19 is so new. There's a lack of knowledge of reinfection possibilities, right? That's not known for sure yet, as far as I know. People without antibodies also, this is a big concern, will be shut out from the activities of everyday life. And what do I mean by shut out? Well, for example, maybe not being able to work, or not being considered for a job. Not being considered for a job because you don't have antibodies yet. Maybe not be able to travel, may not be able to have access to certain facilities, and basically you become socially stigmatized. And the last one there is privacy. And you can't get around this. An immunity passport or immunity stamp is personal information, so there's no way around this one. And what this potentially does is it creates potentially a big divide between the haves and the have-nots. Or in this case, it would be the had, as in had COVID-19, and the have-nots. So these people who have had or had the coronavirus already, COVID-19, they can carry on with the old normal, whereas those who have not may be stuck in a bubble, so to speak, and have a smaller range of things that they can accomplish. But if we throw some of these considerations aside, where might this type of algorithm marriage be useful? So I'm not discounting that this is not a good idea and this won't happen. It's just that there are some issues around it. But if we go back in time, AI algorithms have helped scientists and virologists to understand the genetic properties of COVID-19 much faster than any other virus before. So there's been great success with the use of algorithms and AI. There was great success in quickly finding the genetic blueprint for COVID-19. It took only a month for scientists to recreate this genetic these genetic components of the virus. Now, if we go back in time to SARS, SARS in 2003 took approximately 5 months to genetically sequence that particular virus. The first case of SARS was reported in China in November of 2002. And the CDC in the US reported that genetic sequencing occurred on April 14th, 2003 by scientists in Toronto, Canada. Now, why Toronto, Canada? One of the main SARS outbreaks in 2003 occurred in Toronto, Canada, and a woman who had been staying in a hotel in Hong Kong on the 9th floor of the Metropole Hotel in Hong Kong. I believe they've changed their name because they became quite famous in a not positive way as one of the main starting points of the global outbreak of the SARS virus. So she was on the 9th floor of the Metropole Hotel, and she contracted SARS, and unknowingly, I think she got on a plane and she was already sick, or maybe wasn't feeling the symptoms yet, I can't remember. But she flew back to Toronto, which I believe is where she was from. She went to a hospital when she was sick, and what happened out of that was she infected a bunch of the hospital staff. There were 251 cases and 44 deaths. She infected her son. They both ended up in the hospital, and both of these original patients passed away. Now, SARS, sudden acute respiratory syndrome, has some similar clinical characteristics to COVID-19. And I'm not a doctor, so I'm not going to go into these details, but this is, from my research, this is what I found out. But it had hopefully had a much higher fatality rate, close to 10% as compared to the 2% plus or minus a little bit of COVID-19. So quite serious situation. So in viral outbreaks, what of course you have is you have detailed analysis. And as we know with algorithms, they're great at doing detailed analysis. So traditionally, you can draw a chart where each case is represented in time. And this was done for SARS at the Metropole Hotel. And you can have related events, including contacts with other cases, documented using what's called a transmission map. And this can be particularly useful when the outbreak occurs in a closed environment, like, for example, in a hotel. So it will reveal when interhuman transmission might have been possible, and eventually will help identify contagious individuals. So what if, and I'm just positing this here, when I saw this example and I saw this map, it got my brain thinking, what if using the technologies introduced earlier, so the side-hide on FIDO marriage, where you have you already have this facial recognition immunity passport, or even just information about an individual readily available. Let's look at the Metropole Hotel in Hong Kong for February 2003. So on this slide here, what I have on the right-hand side, and it's quite small there, and I'll distribute these lecture notes after today's discussion. This map was used to identify the risk levels associated with individuals that were at the Metropole Hotel during this time period. So on 21st of February 2003, a fellow named Liu, who many consider, I think, to be patient 0 in Hong Kong, he and his wife checked into room 911, I note, not the greatest room number, on the 9th floor of the Metropole Hotel in Hong Kong. He was what is now known as a super spreader. A lot of you have probably heard this term now. From him, so they deduced 23 other Metropole guests developed SARS, including 7 from the 9th floor. And one of these people on the 9th floor was the woman who traveled onwards to Toronto. So let's just say that with this map here, you can see we have hotspots identified in red, and blue spots, I think, identified rooms that were occupied. Now let's say we have CCTV coverage, which most all hotels have now these days. We could use the facial recognition software from CCTV footage to detect proximity in time. So an algorithm could do this, theoretically. It could, through this footage, find out who is who, again, through that immunity passport, where they were. So for example, were they in any of these what are considered to be hot zones? We could also identify hot zones based on interactivity from this footage. We could identify who they were with, so who was in with them in a small area, what they touched. So if you have high enough resolution, you could theoretically use an algorithm to detect where they were touching and what they touched. And then also, the algorithm could detect proximity to each other. So if you're within a 6-foot radius, how close you actually were, and also for how long. Okay? So from the CCTV footage, an algorithm could theoretically detect all of this information and present it in a useful way. So for example, a rating may be given to each individual based on the results of the algorithm's calculations. So with the side-hide passport, individuals could quickly and easily be traced down and next steps taken. So as we have learned from this COVID-19 pandemic, one of the essential steps of containment is the ability to identify at-risk people and to be able to quickly track them down and to isolate, test, and then also to potentially quarantine them if the case presents itself, if that's what needs to be done. So any application, any process, algorithm that can do this quickly, securely, privately, and effectively will have a good chance of becoming the new normal. Okay, so that's all I wanted to discuss today. I went, I think, a few minutes too long. Just to recap, we talked about and we applied some critical thinking about algorithms, so a more well-rounded approach when we are designing algorithms. The difference between quantitative and qualitative data in regards to algorithms, different approaches to analyzing qualitative data, so human versus computer, socio-technical approach to algorithm design, and then some algorithms and how we may be thinking about algorithm design in this new world of COVID-19. So as you can see, the topic of algorithms is a massive one, and we've only touched the surface. The hardest part of this 3-day webinar series was actually condensing the information into small enough pieces to do in 45 minutes or less. So hopefully I've given you enough to give you all a better understanding of what algorithms are, how they are being used or misused, and how they are all around us. How we can think about algorithms in the context of design, and how we can use a well-rounded approach towards the design process. So I hope that all made sense. Thank you so much for listening. Now let's move over to the responses and questions period. I think we have a few minutes to do that. Just going to take a drink of water. Okay, so these are, okay. So to the poll question, what are some sources of qualitative data that may be useful? Customer feedback, yeah, for sure. I mean, there's algorithms out there these days that are whipping through customer feedback and trying to make sense algorithmically of that information. Personal preferences, emotions, yes, for sure. And I'll go back to that one in a second because I've got an example here of that. Interviews, focus groups, yeah. I mean, as part of my research, because I was dealing with qualitative data, I did a lot of work with interviews. I did both interviews and focus groups. And I manually interpreted all of that qualitative data through the coding process and through categorization. It would have been really nice to have a good algorithm to do that. But these algorithms are difficult to write. Qualitative is inevitably quantitative since no shortage of assignable surrogate metrics apparent. Yeah, I mean, the comment here was qualitative is inevitably quantitative. Well, if you're talking in an algorithmic sense, yeah, I guess you could say so because you're wanting to process that information. You want to run it through a mathematical process. If that's what you're attempting to do, but these days, right, the data is only as good as the algorithm, and dealing with emotional data is still quite problematic because, again, the human language is so subtle, and these subtleties programmatically are difficult to write good algorithms for. Back to the personal preferences, emotions. When I was looking at the research here, I found I'm just looking at where I've got here. Oh yeah, I found an interesting article. So I took a course back in my PhD days that was a social media course around scraping social media data and interpreting it. So there's an article on a website called geeksforgeeks.com, which of course none of you are geeks, but let's just say you were, and you wanted to read an interesting article. There's an article called Twitter Sentiment Analysis Using Python. So sentiment analysis is basically making sense of emotional responses excuse me, to a particular event, a particular article, a particular situation. And we know, of course, these days there's lots of inflammatory information that ends up on Twitter. Excuse me, I'm losing my voice. But what you can do with Twitter is you can write a simple program in Python, and I would encourage you to go take a look at this article. It's not that complicated a code. And Twitter has a built-in library called Tweepy, T-W-E-E-P-Y, and you can use it to access the Twitter API and scrape data. So what you can do is you can scrape data off the Twitter feed. This is legal. They provide the API. I think you just have to register and say you're not going to use it for unlawful use and unethical use. And what this API does is it scrapes the data and cleans it, and then it analyzes it. So what you can get from a feed is, in this case, it gives a response, so a comment, a positive, a negative, or a neutral classification on that particular feed. So what you can do is you can create your own engine or your own algorithm that can give sentiment analysis on how people are responding to this particular tweet or this particular retweet, whatever it may be. So again, it's called Twitter Sentiment Analysis using Python, and it's on geeksforgeeks.com. On that note, I also had here a note about on natural language processing. It's a subfield of linguistics, computer science, and information engineering. So again, it's transdisciplinary, which is the areas that I find most interesting, particularly when we get into qualitative and social communication and AI. It's concerned with the interactions between computers and human languages, right? And particularly how to program computers to process and analyze large amounts of natural language data. And there's lots of research that still needs to be done in this domain. So if it's an area you're interested in, I'm sure you can find a niche in there where you can do some good work. Any other comments here? Says, thanks for the 3-day webinar. Well, they said I presented it well. That's nice. Thank you. Yes, algorithm is a tool we can use to the advantage of our everyday life indeed. Yeah, actually for me, this webinar has been awesome because I finished my PhD a number of years ago now, and I haven't gone back down this path since then. And so it's fired my brain back up again about doing more research and doing more reading in this area again. Yeah, okay. And somebody said we have some audio issues, but glad there haven't been any audio. So we've got the audio issues sorted out. I am what we call the guinea pig. I am the initiator of this webinar series. So I'm being used I think I'm being used on a trial basis. So I'm raw. I'm not mature as far as the Chulalongkorn School of Integrated Innovation webinar series process. I am the raw version, so to speak. If we can turn it back into what I've been talking about. Okay, I think we're pretty much out of time. I think that's. So I just want to summarize. Just in closing, we covered a lot of ground today, and we went off in some very faraway places. To try and bring it all back together, I would suggest this. So we've seen examples of qualitative thinking and how it is different. I think there's no doubt about that. The subject areas of expert systems, the Fisher people example in Granada, machine learning, word cloud, sentiment analysis, and natural language processing, they're a great place to start when you're looking at how to make sense out of qualitative data. So if you feel like you're lost, go take a look at those 3 terms, and you'll start to be able to piece together how algorithmically we can think about qualitative data. Data is all around us, right? Making sense of it all, of course, is a huge challenge. It is here that algorithms can be our friends, and they can also be our companions. So thank you very much for being a part of this. Remember to follow us on Facebook and YouTube to get the latest updates on the upcoming webinars. Please tune back in on Monday, June 8th, from 4 p.m. to 5 p.m., so different time slot, so 4 p.m. to 5 p.m. Bangkok time, to Dr. Gilles Gorel, who will present on the topic Critical Thinking, CK Theory, and its application on Cirque du Soleil. Cirque du Soleil, I've been to a few Cirque du Soleil shows. They're fantastic. If one ever comes to Bangkok, I would highly encourage you get tickets and go see it. I'm not sure if it has been here before, but if it does come, I would encourage you to go. I'll be tuning in for sure because it's something that I find very interesting, and I hope to see you all there, and bye-bye for now.